Hello, and this is the first of hopefully many videos that I'm gonna make this year, just to show you a few things that you can do with the cast, and I'm air quoting a few things. There are a lot of things that you can do with the cast, and the idea here is you want to do as much practice as possible regularly, so hopefully you can improve on your speed, your reaction, your ability to find letter C, because you can't, people just stare at the keyboard for like a very long time typing a word in. Anyway, I don't even know what I'm talking about. Let's just start with question one. So hopefully you have this worksheet in front of you. Which of the following is a true statement for the graph of y equals to -2 of x over x minus 1 squared plus 3? This is the type of questions that the CAS is designed for, and you really want to use a CAS for it. You probably get one or two at least in the exam. And it's the type of question that has multiple options, and you have to go through each one to eliminate the wrong one or eliminate the right one depending on the question. In this case, I'm going to have to go through every single one just to get to the true statement. And because the question is talking about the graph of the function, I'm going to sketch this graph. So I'm going to add a graph page and put this in. Now I'm going to try to go as slowly as possible. At the same time, I am aware that I do move too fast sometimes, so if that happens, just pause the video until you can catch up or something. You know, that's the beauty of the video. Here's the graph, which is an inverted truncus. I'm going to start with the equation of the horizontal asymptote is y equals to -3. One of the limitations of the CAS, especially the graph page, is that it doesn't show the equation of the asymptote. It doesn't show anything that's actually not part of the graph, and technically speaking, the graph doesn't touches the asymptote, which is why you don't see it. At the same time, you can always sketch this line y equals to -3, and just to see whether it's actually the asymptote. Now, in order to sketch this, there are a few ways to do it. The quickest way is just to go to here and tap, and a new input function will come up, and you can simply put in -3. You don't need to write y equals to -3 again, because f2 of x already implies -3. Sorry, f2 of x already implies y. Okay, so if I enter, this is y equals to -3. It's actually down here, so it's definitely not the asymptote. The asymptote for this function actually occurs at y equals to 3. And if you want to check that, you can sketch that line y equal to 3. Now, again, I could just tap, but there is another way to do it. If you really want the letter y to appear, if you either go to menu, actually, you don't necessarily have to go to menu. Okay, if you just delete this whole thing, because once you delete the equal sign, this will come up whether you want y instead of f3 of x, or you want a relation. So in this case, I want y, and I want y equals to 3. So it just comes up as y instead of f2 of x, but they really are the same thing in this case. And hopefully it looks like it's going to cut. It's not going to. It's just going to get very close to this asymptote. So y equal to 3 is the asymptote of this function, of the graph of this function, and y equal to -3 is not, which means that A is incorrect. Moving on to B. As x is approaching infinity, y is approaching 0. Clearly that's wrong. X approaching infinity means as x gets bigger and bigger, and if you just look at the graph, y is approaching 3. So B is incorrect. Part C. The y-intercept has coordinates at 0, 1. It kind of looks like it, but if you want to be 100% sure, you could analyze graph or trace. I'm going to trace, which is, so you go to menu, number 5, trace, and I'm going to graph trace. Perfect, it's that right there. So the y-intercept does occur at 0, 1. So C is the answer, but just to do a little bit more practice, let's just look at D and E to confirm that they're actually incorrect. The equation with the vertical asymptote is x equal to -1. So once again, the x asymptote is not going to be shown, but if you want to check that x -1 is not the asymptote, you can sketch the line x equal to -1. I'm gonna tab just to get it out. Okay, this is already in relation mode, so I can just write x equal to -1, and it's here, which is definitely not the asymptote. I think the asymptote occurs at x equal to 1. Actually, if you want to check, you could do that too. There's your asymptote. So your vertical asymptote is at x equal to 1, and the horizontal asymptote is y equal to 3, which is something that you could deduce just by looking at the function. But let's just imagine that you're very stressed and you don't remember any of this, or you make a silly mistake. It's still a good idea to use a CAS to double check everything. Lastly, the x-intercept has coordinates. I need to move this. Okay. Has coordinates at 0.22 and 0. There are two x-intercepts, one here and one here. I'm going to find the coordinates of them. So you could trace, or you can do analyze graph, because the x-intercept is a 0. So we're going to analyze the 0, and it's going to ask you which graph. We want to select that graph. And lower bound, so just click on the region on the left side of the asymptote, upper bound on the right side. Now, it can't find both intercepts at the same time. So this is the left asymptote, which occurred 0.184. Now clearly this one cannot be 0.22, it has to be bigger than 1, but if you want another practice on how to find it, go to menu, analyze graph, 0, select the graph, and then find lower bound and upper bound. So the two x-intercepts occur at 0.184, 0, and 1.820, which further confirms that C is the correct answer. There's question 1. Simple skills that you want to be able to do, which is to use the graph page to sketch. You need to be able to sketch both horizontal and vertical line, and you need to be able to find the x and y coordinates. The other limitation of using the graph page is that it doesn't give you exact values. Everything will be in approximations, but it's okay. If you really want the exact value, you can solve, I guess. Okay, that's question 1. Let's move on to question 2. And I really want to show you a few things with question 2. So we have two functions, f of x and g of x, and you need to work out which one of these is correct. This is another pretty common type of question in the exam, and this is what define was made for. Okay, define is in the calculator, so I'm gonna control I, which will open a new page, and add calculator. I'm going to define f of x and g of x. There are a few ways to define a function. First method is to type the word define. So you see how it goes from italic to non-italic. That's an indication that this is an actual command in the CAS. So we're going to define f of x equals to, and we're going to put in, not that, a fraction, 1 over x. So it's defined. Now if you want to check that you have defined it properly, now when I type in f, it's bolded, so it's stored as something. And if you go f of x, it's 1 over x, so it has been defined. The second way to define is to go to menu, action, and then define, and that will come up and you do the same thing. Or the third way, which I don't actually use very often, mainly because people look back and have no idea what it was doing. But if you go to control and click on this button right next to the little book, this will come up. It's 2 dots followed by equal. That's the shorthand for define. And you can put in the second function, which is 2 times x minus 1 over x plus 3. Okay, if you want to double check that you have defined g, if I type in g is bold, so that's good. And if I put g of x, there's my function. Excellent. All right, which one of the following is correct? Now, whenever they have a question like this is implying that for every single value of x, this is true, not just for one specific value. Because obviously, if I solve, I potentially can have an answer for x. But if you want this to be true and the question doesn't give you any extra information, it's implied that for which of the following this is true for every single value of x. Now, before we answer the question, I want to show you what that means. So, for example, if I have x equal to x, this equation, which is very obvious, this equation is true for every single value of x. Regardless of what x is, obviously, x will equal to x, which means that if you type that into the CAS, I just pointed at the screen and that doesn't do anything, and type enter, it will say true. However, if I type in another equation, x equals to 2 times x. Now this equation, it's only true for some values of x, not every single value. By some value, I mean one value, which is 0. If I type that in and enter, it will just repeat it because this statement is not true all the time. But it's not false all the time either, so you can't say this never happens. If you, however, write something like, well, let's see whether this works, is less than 0. This one actually also, they just repeat it for you. But if you write something like this, it just say false, like that's just ridiculous. Okay, I think I understand why this can be false. Anyway, so, sorry, this can be true for some value of x. That's not real, but anyhow. So if a statement is true for every single value of x, when you type it into the CAS and enter it, it will come out as true. If it's only correct for some values of x, the CAS will just repeat the statement. And if there is no value of x for which it exists, it will come out as false, which I don't think will happen in this case. So what I am going to do is I'm going to type every single statement into the CAS and see what happens. So my first one is g of x. Once again, it's bold because I have defined it. Equals to 2 minus 7 times f of x plus 3. Enter, it say true. That's good, which implies that for every single value of x, g of x would equal to this. I'm going to continue with the other statements to see what happens. And also talk about this. Okay, 2 times f of x plus 3 minus 1. So this is the second one. See how they just repeat it, but they just write what the equation is without saying true, because this is only correct for some values of x, but not for every single value of x. And if you click on this, it will say domain of the result may be larger than the domain of the input, and that's okay. All right, moving on to C. 2 times f of x minus 1 plus 3 is C. Again, the CAS just repeats the statement. It's not correct for every single value of x. For f of 2 times x minus 1 plus 3. There you go. Again. And 5. F of 2 times x minus 1 plus 3. So for every statement except the first one, the CAS just repeats it because the other statements are not correct for every single value of x, which means that A must be the answer for question 2. It's a neat little thing to be able to do. All right, similarly, we have question 3. Which one of the following functions satisfies this equation? Okay, so now you have 5 different functions and you need to work out which one will this be true for every single value of x. So what I'm going to do is I'm going to redefine f. So it's bold because it's already defined as 1 over x before, but you can over define it. It's okay. Unless you really want to keep f of x, in that case, you do need to start a new document. Now, if I type f of x, it's now defined as square root of 2x, which is part A. And what I'm going to do is I'm just going to type this statement in to see what will happen. Okay. All right, so it looks like it's not going to be correct for every single value of x because the CAS just rewrites the equation. So we're going to redefine f of x now as b. You can call it something else, but I don't think it matters. I've already done enough for a. So that's b. Another thing that you can do, which is very handy, instead of rewriting this entire equation again, you can simply use this arrow. So look at the CAS, the black part. I'm pointing the up arrow. So if you do that, so see how that is highlighted as you go up, and then that's highlighted, and then that's highlighted, and that is highlighted. And now we just enter. You're gonna copy and paste the entire sentence again, so you don't have to retype the same thing again and again. However, this time is using the new f of x that you have just redefined. So it doesn't look like it's true either, because they just, well, the cast, they just rewrite the statement. So continue with the C, 2 to the power of x. This is C. I'm gonna highlight it and copy and paste again. Doesn't look that good. D. D looks promising. So log to the power base 10 of x. Ooh, good. So that's implying that this statement is true for every single value of x, if that is f of x. And lastly, equals to 2 over x. Okay, so for every function listed here, except for d, this statement is not correct for every single value of x, so in that case, D is going to be the answer for question 3. And then we have something similar. All right, you have 3 functions. Let f, now you get the gist of it, so I guess what you can do at this point is to pause this video or fast forward to see whether you can do the same thing that I just taught you for question 4. So if you want to do that, let's pause the video here. Yes, we're gonna try this ourselves. But if you have no idea what I'm doing, then I am continuing with question 4. You have 3 functions, and you need to work out which one of them satisfies this equation. So if you want to define all of them at the same time, you can, or just call the first one 4 times x. Okay, and then we have f of 2 times x plus 2 times y equal to 2 times f of x plus 2 times f of y. Yes. Oh, syntax error. Yes, sorry, that's a plus. It's true, so it works for 1. Redefine. I just don't like to use multiple letters, and then I don't remember which is which. X over 2. It's true for 2. Is it true for 3? So we have x squared over 2. So it's only true for the first and the second one. 1 and 2 only. That's it. Question 4 done. Hopefully some of you have done this without watching what I just said and can now do question 5. Now question 5 and question 6 is a different thing that you can do with the cast. I think I'm going to create a bit more room here because I don't like... Okay, so 5. Consider the function with this rule. You need to work out the maximal domain of f. Alright. Maximal domain is another name for implied domain, and the easiest way to find it is to ask the cast, what is my maximal domain? So type domain. See how it's a command? It goes from italic to normal. Bracket, type the function in, 1 plus square root of x plus 5. Get out of that comma, x. There's your domain. Oh my god. It's mind-blowing. Right, what is this? Including -5. So E. Like literally, that's all I am going to do because I have the cast. I know you probably want to show that you know to find the implied domain, and by all means do it with the non-calculator exam, but this is the easier way. And it also works when you have something like question 6, which I think at this point you can, again, pause the video and try to do this yourself. You just need to type in domain. Yes, pausing the video. Oh, don't type y equal to though, just the actual function part. Anyway, if you're not pausing the video, then I'm just gonna do this. X squared minus x minus 6 over 4 plus 3 times x minus x squared, comma x. Okay, so it's between -2 and 1. or between 3 and 4? Sorry, -2 and -1. So answer is D. Okay, and then we have letters. Let's see how good this is. See whether we can actually do this with letters. I think we can actually. Otherwise, you know, you have to do actual maths. Oh my god. 3 times x. Ooh, okay. Oh my god, this is like, okay. They actually tell you a, b is greater than 0. So the domain here is a little bit more complicated because there are so many different possibilities of what a and b can be. I think you can read this and figure out, so the one that works when a is greater than 0, it looks like this one, but I just want to double check whether I could put in the condition here. Yeah, I can. So yeah, you can put in the condition. Can you put in both condition? Yep, there you go. Put in the condition, and then you have the domain between -infinity and b over a. Sorry, that sounds really weird. All right. Lastly, I think this one you kind of have to do some math, so unfortunately, fun times is over. Question 8 and 9 give you the range and ask for the domain. The domain could be either of those. A few ways to do it. First of all, just to make life a bit easier, I'm going to define f of x as this function, 3 times x, probably should put an equal sign there, minus x squared. Okay, there's the function. The range is between -18 and 2, and you need to work out which domain will work. You can either sketch this function, the graph of this function 5 times, and then work out the domain and range. Or what I can do, I think, is I'm going to try to find which x value will actually give you this range. So we have f solve f of x equals to -18. Solving for x, it's either -3 or 6. And if you solve f of x equals to 2 for x, is either 1 or 2. Okay, let's see what the graph looks like. All right. So -18 is, I mean, you can change the scale. Let's go to -19. Okay, so -18 somewhere here, and 2, where is 2? Okay, this is 2. So -18, actually I think I have found the negative. I think this is actually a bit faster. All right, -18 is here, and 2 is here. In order to kind of cap them off, I have sketched the line y equal to -18 and y equal to 2. So we're just going to find the points. Wow, you know what? I actually have never thought of doing this. Most of the time I do this with, most of the time I do this by hand. But this is purely cast. Let's not actually write anything. So the first point intersection is here. The second one, analyze graph. I'm trying to find the point intersection between the graph and the function. Okay, menu, analyze graph. We're going to do the same thing up here. Graph, function. 1, 2. We learn new things every day. It's not new, but I normally don't go with this. Okay, so essentially this is -18 and this is 2, and also keep in mind that they are exclusive in the question. So if it goes from 1 to 1, which is here, to 6, it's definitely going to exceed 2, because 1 to 6 mean that it's gonna go to the turning point, which is up here, just a little bit above -2. So it's not A. So B, we're going from -infinity to 3 over 2. Don't even know. Okay, where 3 over 2 is. Actually, 3 over 2 is here. I think 3 over 2 is actually the maximum. Yeah? Yeah. So the maximum value or the turning point occurs at 3/2. If you go from negative infinity to 3/2, again, your range is going to be bigger than 2, so you can't do that, which means B is wrong, and so is C, which is just the positive part, like the other half of the parabola. Also doesn't work. It will go from 3/2 to 6. Once again, it doesn't work because as long as you start or end at 3/2, it's the range is going to be too big. So the answer has to be from 2 to 6. So you can actually cap it off between -18 and 2. So answer is E. I like this method. Okay, let's see whether we can do something similar for question 9, which actually is so much easier. But let's just do that. If you got anything I just said, you can try to do 9 yourself. This is your time to pause the video and just check the answer. Otherwise, I'm going to start a new page. Ooh, that is not possible. Okay. Let's type in 4 minus 2 times x, which is this. And we're given the range, which is between -2 and 8. So I'm just going to try to find it on here. So I'm going to sketch y equal to -2, which is here. Y to the 8 is, well, just put it up. Okay. It's here and here. So what I'm going to do is I'm going to try, don't move the graph. I'm going to find these point intersections. You definitely can do it by hand or use the solve function. I actually find this a little bit better, especially if your graph is a curve and you have multiple points. So that's the first one, and then analyze graph intersection. This is the second one. Okay, so we need to find the function between a and b inclusive. You need to start with -2 and end with 3. So a equal to -2 and b equal to 3. And we're done. We are done. That's it for the first edition of Task Calculator, how to use. Until next time.